Hello students, I am explaining chapter 2, Is Matter Around Us Pure for class 9 science. And in this video, I am going to explain the next topic, that is what is colloidal solution. So here we are going to study what is colloid, what are the examples of colloid, then properties of colloid, and the very important thing that is called as Tyndall effect. So let's start. So till now we have studied what is suspension, and even we have studied what is a solution. And now the third one which we are going to start, that is what is colloidal solution. So see here, colloidal solutions are also called as colloids. Colloids, colloidal solution, both are same. So what is the definition for this? A colloid is a mixture in which very small particles of one substance are evenly dispersed throughout another substance. So what is colloidal solution or what is colloid? It is a mixture in which very small particles of one substance are evenly dispersed throughout in another substance. So see the difference between suspension and the colloid. In suspension also there will be two substances, but one substance particles will not be very small. The particle size will be little big and it will not be mixed evenly in the another substance. That is called a suspension. Just now I have explained in my another one video. Already I have uploaded, you can watch that video. I gave the example of chalk powder, or you can take flour, rice flour or a wheat flour, and these we can mix it in a water. So when you see such type of solution, particles will not be very small, and even these will not be evenly dispersed or mixed, uniformly mixed in whole this water. That was called as suspension. But in case of colloid, particles will be small and they will be evenly dispersed throughout in another liquid, or sorry, another substance. So what should be the particle size? Because this definition little bit it is seems to be equal with the solution. Even in solution we can see particles will be very small and they will be evenly distributed. But there is a difference between solution and the colloid, that is based on particle size. So see here, larger than molecules but smaller than in suspensions. So see here, the size is larger than molecules but smaller than suspension. Means in suspension the size is big. That's why they'll settle down. And too small to see with the naked eyes. So we cannot see the particles with the naked eyes even in case of colloids. Now, the next is appearance. How the colloidal solution looks. It looks homogeneous. Homo means equal, so evenly mixed. So remember, colloidal solution is also homogeneous, that is evenly mixed, but it is actually heterogeneous because the particles are distinct and dispersed. It is a homogeneous, it looks homogeneous, but actually it is heterogeneous because the particles are distinct and dispersed. Example is milk and mist. So you maybe have seen milk, liquid particles dispersed in liquid. Remember, what is milk? In milk, one liquid particles are dispersed in another liquid. Next is mist, liquid droplets in air, liquid droplets dispersed in air, like this also we can say. Now you can imagine the solutions of salt and water and milk. So in case of milk, you can see it will be having water as well as the pure milk, but you can see little bit of whitish in the appearance. But salt and water, if you see, it will look like complete water. You cannot see the salt. Even there will be no color for this solution. Salt will be completely evenly distributed and these particles are very, very, very small. That's why we are not able to see any color in this solution. All are evenly mixed. Even in milk, they are evenly mixed, but still it is a heterogeneous because particles are distinct and dispersed. So this is the difference between solution and colloidal solution. Suspension is totally different because in suspension particle size will be bigger compared to solution and colloid. But in solution and colloid we will get confused. So in solution, remember, particles are very, very, very small and it is homogeneous. But in colloid, particles are small, it looks homogeneous, but actually it is a heterogeneous. Now we'll study a little bit extra from this colloidal solution. There is one important topic which is called as Tyndall effect. Very important, many of the time question will be asked from this topic, that is what is Tyndall effect. So this Tyndall effect we can see in case of colloids. What is the reason for this? The reason, and before going to the reason, first see the definition. The scattering of a beam of light by colloidal particles is called Tyndall effect. Whenever we pass a beam of light through a colloidal particles or colloidal solution, the particles will scatter the light, and that's why inside the beaker or inside the colloidal solution, path of a light is visible. Remember, path of a light is visible, and such type of effect is called as Tyndall effect. So this is the definition. And what is the reason for this? The reason is size of the particle. So see here, very important reason. Colloidal particles are large enough to scatter light, unlike true solutions where particles are too small. The example is what? Salt water or sugar water. So in salt water and sugar water, particles are too small. They are not enough in size to scatter the light. So the beam of light is not visible in salt water and sugar water, that is homogeneous solutions. But in colloidal solution, the beam of light is visible. To look, they are homogeneous, but still they are heterogeneous. The particle size is large enough to scatter the light. So if the question comes, what is the reason colloidal solutions show Tyndall effect? The reason is particle size in colloidal solution is enough to scatter the light. I hope you understood the answer for that question. Now, observations in daily life. In our day-to-day life, there are so many examples where we can see this Tyndall effect. First one, a beam of sunlight passing through a forest canopy scatters in mist. You maybe have seen in a forest, there will be many trees, and in between the trees, the sunlight will be coming from the top. And when the sunlight passes from these in between the trees, there will be so many air molecules or dust molecules in the atmosphere. For example, imagine if these are the trees. Just imagine, let me draw something here. So imagine if these all are the trees, and from somewhere on the top, from here, if the sunlight is entering into the forest, imagine like this, the sunlight is entering. When this light is entering through the forest, here there will be so many dust particles into the air. So dust particles present in the air, it is nothing but one of the example of colloidal solution. Dust particles in air dispersed, it is called a colloidal solution. So these all dust particle size is enough to scatter the light. So when this light is coming from this hole, these particles all will scatter the light, and that's why the path of the light which is coming from the sun will get spread like this. You maybe have seen into the forest, and this is also the example of Tyndall effect. Then the next example is dust particles in a sunbeam entering a room scatter the light. So remember, even in a room, we can see Tyndall effect. So how we can see, just imagine if this is a house. See, if this is a house, and somewhere here on the top of this house, if there is a small hole, or somewhere on the window, if there is something little bit of portion is open, from that portion, the light coming from the sun can enter. And once it enter, the light when passes into the house, it will spread. The light, beam of a light will get spread like this. Why? Because in the house there will be so many dust particles present in the air. These all dust particles will scatter the light, as I have explained in the forest. So in forest, there will be dust particles in the mist, or the water particles, water vapors will be present. Even in a house, there will be dust particles in the air. So these all are responsible to scatter the light. And that is why we can see the beam of light spreading in the house or the forest. Even on the stage, if somebody is performing, and if there is a focus light here, when the light is on from this focus, it will, you can see the path of the light, it will spread like this, and the person will be standing somewhere here for the performance. So why the beam of light will get spread? Because there will be so many dust particles into the environment. These all dust particles will scatter the light which is coming from this focus. So these all are examples of Tyndall effect. I hope you'll understand. Any example can come in the exam, and they may ask you give reason. So you have to remember this Tyndall effect. What is the significance of this? What is the use of this? Helps distinguish colloids from true solutions. So the significance is, or the importance of Tyndall effect is, it will help to distinguish or differentiate between the colloids and the true solutions. True solutions will not show Tyndall effect because particle size is very small, not enough to scatter the light. But colloids can show Tyndall effects because the particle size is little big, which is enough to scatter the light. So if you want to differentiate or if you want to identify which is colloidal solution and which is true solution, we can use this Tyndall effect or perform this Tyndall effect, which is very simple. You can take a torch and apply the light, beam of a light, pass this beam of a light on the solution in which you have to identify. And if you see the beam of a light, then it is a colloid. If you are not able to see the beam of a light in that solution, then it is a true solution. So this is the experiment which you can use. That is the significance or the importance of Tyndall effect. I hope you will understand what is Tyndall effect. Now I'm going to move to the next topic. Now we are going to see properties of colloids, same like true solutions, same like suspension. Now we have to see the properties of colloids. First property, heterogeneous nature. So colloid is a heterogeneous in nature. A colloid is a heterogeneous in nature, and what is heterogeneous? Its particles are too small to be seen individually with the naked eyes. Second property is light scattering, that is Tyndall effect. Just now I have explained. Colloidal particles are large enough to scatter beam of light, making the path of light visible. Actually, if you compare the size of true solution and colloidal, then the colloidal solution particles are large enough to scatter the light. Otherwise, in colloidal solution also particle size will be small and they will uniformly spread or dispersed throughout in the second solution. Third one, stability. What is stability? Colloids do not settle down when we left undisturbed. Remember this, if you take milk into this beaker and if you mix water in this, if you keep this undisturbed, the milk particles do not get settled and the upper solution will not become clear. Remember this, milk will remain as it is if we keep it undisturbed for any time. So that's why colloids do not settle. This makes them stable mixture. That's why these are stable. Fourth one is filtration. Filtration, as I told, by taking funnel and a beaker, filter paper. Colloidal particles cannot be separated from the mixture by ordinary filtration. If you transfer this milk which we have taken in a beaker from a funnel having filter paper on it, then milk particles, proteins, fats do not get settled into the funnel. As it is, milk will come down into the beaker as a filtrate. So we cannot separate milk particles from a milk particles and a water. That's why ordinary filtration method cannot be used for separation. Centrifugation can be used for separate colloidal particles. So there is one method which is called as a centrifugation, a special technique which is used to separate colloidal particles. So these are some of the properties of colloids. I hope these all the points will help you to prepare for your exam. Now we'll move next. Now the next is components of colloids. Very important. Whenever we want to prepare colloids, we should have two components. One is called as dispersed phase and the second one is called as dispersed medium. Remember, dispersed phase, dispersion medium. What is dispersed phase? The solute-like component of a colloid. So dispersed phase means it is a solute-like component which will be present in small amount. Remember, it will be present in small amount. Consist of tiny particles that are evenly distributed throughout the medium. So this whatever solute-like component is present in a colloid, which will be present in small amount, it consists of small particles and these all small particles will get evenly distributed in the given medium. Now, what is dispersion medium? The substance in which dispersed phase is suspended. So, medium means it will be present in large amount. So, it is a medium in which this dispersed phase is uniformly, evenly distributed and in which dispersed phase is suspended. So, acts as the carrier for the colloidal particles. So, this large amount of substance that is called as dispersion medium, it is acting a carrier. Like for example, if I say milk, in the milk we have water large in amount. So this becomes dispersion medium. I'll write DM, dispersion medium. But the particles or the substances like proteins present in this milk or the other substance present in this milk, these all will act as dispersion phase because these are present in small amount and the water is present in large amount. So in this water, these all the particles like proteins, fats, etc., these all will remain suspended and the milk will get white color. So always remember, dispersion phase or dispersed phase will remain suspended in dispersion medium. So medium will be in large amount and dispersion phase will be in small amount. This is the main important thing which you have to remember. If you know this basic thing, then we can write the dispersed phase and dispersion medium for any examples. So here there are some of the common examples which I have taken from your NCERT book itself. So see in this table, first column is dispersed phase, which is present in small amount. Second is dispersing medium, which is in large amount. Type and example. So see here, if the dispersed phase is liquid and dispersion medium is gas, so gas is more, liquid is less, then such type of colloid solution is called as aerosol. So aerosol means what? Gas is more, liquid is less. Example is what? Fog, clouds, mist. Example. So you maybe have seen fog. In fog, large amount of air will be there and small amount of some water molecules will be there. Water molecules. So remember, so here air is dispersing medium and water molecules are dispersed phase. Then when dispersed phase is solid and medium is gas, then it is called as again aerosol, and the example is smoke, automobile exhaust. What is smoke? Smoke is nothing but small amount of carbon particles. Remember, smoke is what? Small amount of carbon particles mixed in air. So that's why the air will become black. You maybe have seen the smoke coming out from the industries. That smoke is coming due to the burning of the fuel. So when you burn fuel or automobile exhaust, small amount of carbon, sulfur, etc., all will mix in large amount of air. And this is also called aerosol. When dispersed phase is gas and dispersed medium is liquid, then it is called as foam. Such type of colloids are called foam. Example is shaving cream. In shaving cream, liquid is more but the gas is less. Same way, now again we are going to change the dispersed phase and dispersed medium. You can understand. When dispersed phase is liquid only, and if the medium is also liquid, means liquid mixed in liquid, it is called as emulsion. Example, milk, face cream. If the phase is solid and medium is liquid, then it is called as sol, S-O-L, milk of magnesia or mud. Then if phase is gas and medium is solid, then also it is called as foam. Example is foam, rubber, sponge, fuming, etc. If the phase is liquid and the medium is solid, then it is called gel, jelly, cheese, butter. These all are examples. If phase is solid, medium is also solid, then solid sol. And here the example is milky glass or colored gemstones. So these are some of the examples of for different type of colloids. So remember, this table is very important from exam point of view because the question can be asked. If the phase is liquid, medium is gas, then the type of colloid is. So it is aerosol. Or it may be asked reverse. If the type of colloid is foam, then what is the dispersed phase and dispersed medium? It is gas and liquid respectively. Or they may ask to give the example of some colloidal type. For example, if the colloidal type is foam, give the example. Then you can give the example from this table. So try to remember this table which is given on this page, even it is there in your NCERT book. So in this video, I have explained colloid topic completely in detail with all the definition, even with the examples of Tyndall effect. This will help you to prepare to understand this topic clearly. And if any question asked from this topic, you will be eligible after watching this video to answer that question. So if you're getting little bit also help from this all the videos, then if you like my videos, share my videos with your friends and please consider subscribing my channel. Thank you so much.